Today's distributive property. We've already talked about distributive property a little. Essentially, this is simplifying an equation to start off. So right now we have one value, which is 3, outside of the brackets. Inside the brackets, there's no more simplifying. If you notice, these terms are not like terms, so I can't simplify this any farther. So my next step would be to take what is outside and see if I can distribute it into each of these numbers, which I can, because it is 3 times everything in the bracket. So what we're going to do is we're going to take this value of 3, multiply it by all 3 terms. And remember, terms are separated by our addition or subtraction signs. Okay? This is technically a multiplication sign between 2 numbers. This is 2 times x, but we consider it one term. So when we multiply 3 times x squared, what's technically in front of that x squared?
1.
1. That's right. So 3 times 1x squared, Jerwin. 3x squared. Good. I did. Then 3 times 2x.
Oh, yes. 6x.
Very good.
6x.
And finally, Jerwin, 3 times negative 1?
Negative 3.
Excellent. Good. Okay, so that's simple distribution. Okay, but what we're going to be focusing on today is distribution when we have 2 sets of brackets, or at least 2 terms within each bracket. So we'll call that example 1. Example 2 is a little more complex. Okay, it is still in function notation, so f at x. But in this case, let's say we have x plus 3 multiplied by x minus 2. Okay, so this is considered distributive property. When they teach it, they call it several different things. Sometimes they refer to it as FOIL, F-O-I-L. Okay. Yes, what does the F stand for?
First.
Okay.
Inner. Outside. Outer. Inner. Outside. Inner. Inside. Inside.
And what's L?
Last.
Good. You learn that, or you're about to learn it now? Good. So here's an example of it. What they're saying is we need to distribute. Again, we look inside the brackets. Neither of these are like terms, so we can't simplify what's in these. So what we're going to do is distribute these. It's called expanding, you could say. So what I need to do is I need to take the first term and multiply it by both terms in the other bracket. And I also got to take the second term and multiply it by both terms in the second bracket. That's usually known as the rainbow method, but we're going to use FOIL. So when we talk about first, we're talking about the first term in each bracket. So we're going to be multiplying those 2 first terms. So we're going to get f at x is equal to, what is x times x?
X squared.
Good. So we get x squared. Okay? The outside terms. In other words, we're looking at the very first term and the very last term in these 2 brackets. What is it, German?
Negative 2x.
All right, so we get negative 2x when we multiply those 2 terms. The inside terms will be obviously the opposite of the outside terms, so that will be our 3 and our x. Gerwin?
3x.
Good. And finally, our last terms are the last terms in each bracket. 3 times negative 2?
Negative 6.
Excellent. Okay. What you guys need to notice now, with my underlining, is each term has been used twice. That's very important when we go through this. Okay? They have to be used an equal amount of times. Now that we have this, we do collect like terms. Our 2 terms in the middle are like terms. Negative 2x plus 3x. Anyone know what that will become?
X.
That's right. So we're going to be left with f at x is equal to x squared plus x minus 6. And that's it. We now have 3 terms. None of them are like terms, and we're set. Okay?
Follow me, hyphenation 18. YouTube.
So I put up a second question here. Same idea. We could use FOIL to solve this, but I'm going to show you something called the rainbow method. It's pretty much the beginning of what I started with. So the rainbow method, we're going to take the first term, and we're going to multiply it by both terms in the other bracket. You can, yeah. And you can take the second term, and you need to multiply it by both the terms in the other bracket. So when we do this process, our very first one is going to be negative 2x times 3x. That's going to give us negative 6x squared. Okay. Then we multiply negative 2x times negative 5. That's going to give us positive 10x. Then we do the second value in the first bracket times both. 1 times 3x is just positive 3x. and 1 times negative 5 is negative 5. Again, if you notice, very similar to the last question we've done with FOIL, we have 4 terms here. We need to collect the like terms, and the like terms happen to fall right in the middle. So we collect those like terms as our last step. We're left with negative 6x squared. 10 plus 3 is 13x minus 5, okay? So whichever method you find easiest to use, go about using it. Both are correct.